So now I'd like to take that sum that we looked at, 1/2 plus 1/4 plus 1/8 plus ... and look at our formula for a finite geometric series. So if we're looking at a finite geometric series, so at some point if we just stopped and we stopped adding up the terms, then we would use this formula here. So A1 would be equal to 1/2, and the ratio is also 1/2. So now if we're looking at this formula and we're saying we're going to add up infinitely many terms, well, we would take that first term, which is A1, and then we would do 1 minus 1/2 to the nth, but that's infinity, all over 1 minus 1/2. So if I take 1/2 times 1/2 times 1/2 times 1/2 times 1/2 and keep going, the numbers keep getting smaller and smaller and they go to 0. So this approaches 1/2 times 1 minus 0 over 1/2, because 1 minus 1/2 is 1/2. So 1 minus 0 is just 1, and you get 1/2 over 1/2, which is just equal to 1. We can look at this in another way. If we look at these, each of these things here are called partial sums. So we're summing up the infinite series partially. So if we just sum up the first term, we get 1/2. If we sum up the first two terms, we get 0.75. If we sum up the first three terms, we get 0.88. The first four terms, we get 0.94. The first five terms, 0.97. 6 terms, 0.98. 7 terms, 0.99. And 8 terms, if we round to 2 decimal places, it actually is equal to 1 at that point. So we know that it's not exactly 1. So now what you can do is you can graph the partial sums. If you take the number of terms on the x-axis and the actual sum on the y-axis, then you can graph them. So we're plotting the points 1 1/2 to 0.75. Okay, and actually you can see the values on the graph here. Use yellow to highlight, right? So we get this point, this point, this point, this point, and we can see what happens is it approaches the line y equals 1.